Whenever a function calls itself, it's called a recursive function. It is doing a recursion, the act of a function calling itself. Recursion is a popular technique to solve problems with inner problems. It will call itself continuously until a condition is met. Take this array of numbers, for example. I want to know the sum of all numbers, and I can create a total variable that will contain my answer, then loop through the list and count it, then log the total. Pretty straightforward. A go-to reason to use a recursion is to replace complex loops. But this one is simple, just for demonstration. So to create a recursion, I create a function named count, which takes an array of numbers. The first thing I do is remove the first number and store it in the n variable. Then I check if the list still has numbers and return n plus the result of calling count again with the remaining array of numbers. Otherwise, I just return n. Now if I console log the result of calling count, I got the same result. If you look at this recursion, it might not be clear what's going on. So this is what's happening. I get the list of numbers, remove the first number, and then return the sum of the first number and the result of count call, which will return the next number plus the result of count call of remaining numbers, and so forth, till you reach the point where the list does not have any more numbers and it just returns the last number. Then I start solving right to left. I sum the last pairs until I end up with just a total, a single number. Recursion is great when you start working with trees, a graph, data structures, where you do too much repetitive stuff. And loops alone could be very complex and hard to make sense out of it. Recursion is not a more efficient solution as in time it takes to execute something, but it can be a less complex one at times. There is a catch though. Continuously calling the same function may cause a call stack error. Different environments and environment versions may have different call stack limit. Whenever you run into this problem, you may opt to some other solutions or try to optimize your solution till you get there. A direct recursion is when a function calls itself by using its name. But you can also have indirect recursions where a function calls another function which ends up calling itself. Recursions can also be single or multiple. A single recursion is linear from start to finish, and a multiple one can deviate during the condition, then come back and continue. Just to leave you with another example, a common example you may find for recursion is to calculate the factorial of a number, or Fibonacci. Factorial of a number is achieved by multiplying all the numbers from 1 up to that number. Again, I could use a loop like this to do it, super fine. I could also write a factorial function that returns n times the result of the call with the n minus 1 and stop once the number reaches 1. Very similar from previous problem. Like, share, and subscribe for more content like this. Thanks for watching. Catch you in the next one. Bye-bye.